will talk about the statistic. What is statistic, by the way? A journal written by Jim Frost said that statistics help us to broaden our knowledge in using a proper method to collect data, make use of correct analysis to constructively present the outcome. Statistics make us understand certain things much deeper. For me, statistics requires so much effort to understand certain phenomena. It is indeed a thrill and full of discovery. Moreover, according to the same, statistics is a branch of mathematics that deals with a collection, classification, description, and interpretation obtained by conducting of surveys and experiments. Its fundamental purpose to describe and draw inferences about the numerical properties of population. To understand it deeper, me and my team prepare certain topics to discuss with you. Let's start. We have a measure of central tendency. This can identify the centrality of data set. These include median, mean, and mode. First, let's start with mean, or also known as arithmetic mean. Okay, this is used to measure the central position. It is the sum of measures divided by the numbers measured in a variable. As the measures cluster around each other, a single value appears to represent distinctly the total measures. Okay, here an example. The age of 10 elderly people in one of the cities in a barangay are 84, 87, 85, 85, 86, 90, 79, and 76. Now the question is, what is the average of age of the 10 elderly people? So we have certain solution by getting the mean. So let's add up all the numbers or the data set. Okay, this will be the total of 832. 832 divided 10. Why 10? It is because the age of 10 elderly people. Okay, this equal to 83.2. Now that's the average or the mean. So now let's move on to the second example. The data show the number of children in a sample of 6 orphanages in Davao City. The 110, 76, 29, 38, 105, and 31. Now let's find the mean. What are we going to do? It's just the same what we did on the first one. Add up all the numbers or the data set, and that would be a total of 389. 389 now divided to 6, and now we have the answer, which is the 64.8. Okay, that's our mean. Okay, so now let's move on to the second, the median, the middle entry in a data set, or the middle number found by ordering all data points and picking out the one in the middle. Okay, to find the median of a given set of data, okay, we have to take note of this, the following. First, arrange the data either increasing or decreasing order. Second, locate the middle value. If there are two middle numbers, take the mean of the two, and that would be the median. Okay, so now let's move on to example. First, we have, okay, the number of books borrowed in the library from Monday to Friday last week were 58, 60, 54, 35, and 97 respectively. Now let's find the median. Okay, now we all have to do is that arrange the number by increasing order. Okay, so we have 35, 54, 58, 60, and 97. So as we can see here, as we arrange the number, the middle number is 58. So now that's basically the median. Okay, the question now is, what if there are two middle numbers? Okay, so here an example. Cora is studying in a certain university under the program of social work, and the following are her quizzes for the second quarter. Okay, we have the 8, 7, 6, 10, 9, 5, 9, 6, 10, and 7. Okay, now let's find the median. Okay, the solution that we're going to use here, same as what we did at the first one. Okay, so as we can see here, we have the two middle numbers, the 7 and 8. So we have to get the mean of these two. So 7 plus 8 equals 15 divided 2, and that would be 7.5. 7.5 is our answer, which is the median. And the last one in measure of central tendency is the mode. Okay, this is another measure of position. And the mode of a data set is the number that occur most frequently in the set. Okay, so for us to find the mode in the set, let's first, select the measure, the number that most often. Also, you can, arrange the number from least to greatest and count how many times number occur. In that way, it's it's way easiest and fastest to find those numbers. Second, if two or more measures appear the same number of times, the frequency they appear is greater than any other numbers. If each this value is a mode, okay, that's one mode is unimodal, and if it's two mode, it's bimodal. Okay, so now let's move on to example. First, the shoe size of 10 randomly selected youth in a shelter are 6, 5, 4, 6, 4.5, 5, 6, 7, 7, and 6. So now let's find the mode. Okay, if you look at the number closely, you can see here that the 6 appears several times. So that's basically our mode. Okay, the mode is 6, since it is the shoe size that occurred the most number of times, and it's unimodal. Okay, so now let's move on to the next example. Okay, the size of 9 classes in a certain school are 50, 52, 55, 51, 54, 55, 53, and 54. So now if you're going to see closely, the mode are 54 and 55. So that means we have the two mode, and that's basically bimodal. Okay, since these two measures occur the same number of times. Alright, so I guess that's all for today's discussion about statistic, and hope that you learn somehow. Again, thank you so much, and see you again next time.
Good day, everyone. The topic that I'll be going to discuss under statistic is all about frequency distribution table. So first, let us define what is frequency distribution. In statistics, a frequency distribution is a list, table, or graph that displays the frequency of values in a sample. Each entry in the table contains the frequency or count of the occurrences of values within a particular group or interval. So this is an example of frequency distribution table. Now, I will show you the steps on how to create a frequency distribution table. A sample of 50 residents in a remote community has been randomly selected. The following data show the residents' ages. Determine the appropriate class interval to use, then prepare a frequency distribution for the data. So below are the residents' ages. For you to solve it easier, you can first arrange the data in ascending order. So it will look like this. It is not necessary to arrange, but I assure you that it will help a lot. Second step is to get the range. The formula in getting the range is maximum value minus the minimum value. So, as what you can see in the data, the maximum value is 76, while the minimum value is 10. Therefore, 76 minus 10 equals 66. So, the range is 66. Third step is to get the number of classes. So, in getting number of classes, we have the formula of number of classes equals 1 plus 3.3 log n, where n is the total population of the given data set. So, 1 plus 3.3 log 50. So, first you have to look for the value of log 50. So, the value of log 50 is 1.69897. So, you have to multiply first 3.3 times 1.69897 is equals to 5.61. So, 1 plus 5.61 is equals to 6.61. 6.61, or you have to round it up to 7. So the number of classes now is 7. The fourth step is to get the class interval. Class interval is denoted by H. So the formula in getting this is H equals range divided by number of classes. So earlier, we solved for range. So range is equals to 66 and number of classes is equals to 7. So 66 divided by 7 is equals to 9.42, or it is equivalent to 10. So after getting those values, we can now make a frequency distribution table. So this is the frequency distribution table. So to find the class boundaries, we take half of the difference between the lower class limit of the second class and the upper class limit of the first class. So 20 minus 19 divided by 2 is equals to 0.5. So this value is subtracted from the lower class limit and is added to upper class limit to get the required class boundaries. So to get the midpoint, refer the values from the class limits. So in here, there are two midpoint. So in 10 to 19, 14 and 15 is the class midpoint. But in making a frequency distribution table, it only had one value for the class mark midpoint. So 14, all you have to do is to add those two middle numbers. So 14 plus 15 is equals to 29, and 29 divided by 2 is equals to 14.5. So that's how you get the midpoint. And for the cumulative frequency, you have to refer the values from the frequency. So the cumulative frequency is coming from the frequency itself. Remember that cumulative frequency must be equal to the frequency. Thanks for listening, and I know you can now perform how to solve and make a frequency distribution table.
Hello everyone, so at this time I will be discussing all about finding the areas in normal distribution or curve. So before anything else, we should know its properties first. So the most important probability distribution in statistics is a normal distribution. It is a continuous probability distribution for a random variable like x, y, or any letters that we can use in the alphabets. So the graph of a normal distribution is called the normal curve or bell-shaped curve. And here are some of the important properties of a standard normal distribution. Number 1, the mean, median, and mode are all equal. Number 2, the normal curve is bell-shaped and symmetric about the mean. Number 3, the total area under the curve is equal to 1. And number 4, the normal curve approaches but never touches the x-axis as it extends farther and farther away from the mean. So now we will be discussing the guidelines in finding areas under normal distribution. So we have here an example how to find the area to the left of the z. So in finding the area to the left of the z, we need to find the area that corresponds to the z in a standard normal table. So what we need to do is to use that table to find the area for the z-score. So if you still don't know how to use the z table, then please visit ztable.net. So after finding the z value of 1.23, I came up with the value of 0.8907. So the answer of the area to the left of z is equal to 1.23, using the z table, it's 0.8907. So another situation on finding areas under standard normal distribution is finding the area to the right of the z. So the rule for this one is to use the standard normal table to find the area that corresponds to the z, just like we did earlier. Then subtract the area from 100% or 1. So 100% and 1 is a constant value. So when we already have the value of 1.23, which is 0.8907, so all we need to do is to subtract 1 subtract to 0.8907, then we have a result of 0.1093. So the area to the right of the z is 0.1093. So we are now down to our last example, which is finding the area between two z-scores. So the things that we need to always do is to find the area corresponding to each z-scores in the standard normal table. So we have here the value of negative 0.75 and 1.23. So the area to the left of the z is equal to 1.23 is 0.8907, and the area to the left of the z equals to negative 0.75 is 0.2266. So all we need to do is to subtract to find the area of the region between the two z-scores. So the 0.8907 is subtracted to 0.2266. So the value or the equal value is 0.6641. So that is the result. So that is those topics are just very easy. So I just hope that you have learned something. Thank you so much for watching.
In almost every endeavor of human activity, the scientific method has proven effective for solving problems and improving performance. This approach involves the collection of information or data pertinent to the particular problem or concern. Statisticians play several important roles in these scientific studies.
And I'll go